Sorry about that. Come on. All right. I was going to have everyone work on example 6, except though I feel I really want to get through the rest of the lecture. So what I'm going to do is go through this one with everyone, okay? Okay. I mean, if anyone has an objection, just you can say something now. I won't get upset. You know, if you want to try it now, that's fine. Okay. So I figured I'll go through this one, then we'll keep going then. Again, I will post the complete set of notes shortly after the lecture, sometime today, that is. So, all right. So for this one, again, we have A is 1, right? We have B is 8, and we have C is 4. So in this case, what's the vertex? Well, again, it's negative B over 2 times A. I know it's over here. Usually I had it over here, but same thing, same idea. So in this case, we get negative 8 over 2 times 1. That's negative 4. Okay, so that's good. And what do we do next? Well, that's the x coordinate of the vertex. To get the y coordinate, we evaluate the function there. I know here I have y equals, but again, it's the same idea. You just replace x in here with negative 4. So we have negative 4 squared plus 8 times negative 4 plus 4, which is 16 minus 32 plus 4, which is minus 12. So, you know, the whole idea in the background is you have y equals f of x, even though I didn't write f of x up originally here, but we do have that. You know, that is the idea. Okay. Where f of x in this case is the quadratic function. So from here we have the vertex, which is negative 4 and negative 12, comma negative 12. You know, this is the vertex. The axis of symmetry is this. I didn't write out the y-intercept, but the y-intercept should be obvious. That's just 4. So let me just leave that off. But again, since A is 1, the graph, points upward like this. Okay, as you can see. The vertex is at the very bottom. See if I can draw this. Okay, this is going to be interesting. Oh, that's not bad. That's where the vertex is. And the range, as you can see, is going to go up. It has to go up to infinity. That is, it's going to be from minus 12 to infinity. Because again, the graph is going up. Okay. And again, if you replace x with 0, you get 4. So we also have I'll write it over here, the y, oh boy, bear with me, intercept, that's 4. Okay. So that tells us the point 0.04 is on the graph of the parabola. Are there any questions on this slide? Okay, for the x-intercepts, right? Again, that's, you know, I had the y-intercept over here, I forgot. But anyway, I have, for the x-intercepts, you know, I mean, you could try factoring, right? We have a trinomial here. The leading coefficient is 1, but you would need 2 numbers, right? Whose product is 4 and the sum is 8. If you try going through that, you're not going to find numbers that pull that off. You can't find 2 numbers whose product is 4, but the sum is 8. So you can't factor this. What I would do then is use the quadratic formula. Okay? Okay. So we have the quadratic formula here. Since we can't factor this, you can't write it as x. You can't write this as the product of x minus an integer times x minus another integer. Okay, well, let's use the quadratic formula. We have this then. So we have minus 8 plus or minus the square root of 8 squared, minus 4 times 1 times 4 over 2 times 1. And you go through it, you end up getting minus 8 plus or minus the square root of 48 over 2. And again, there are two solutions, minus 8 plus radical 48 over 2, which turns out to be a decimal, like this. You can see it's not an integer. It's not a rational number, actually. This is only an approximation. And we have this also, the other integer, the other solution, excuse me. So we do have two solutions. Okay. We have two x-intercepts, that is. We just can't factor this. That's okay. But we can still get the graph. And here's what the graph looks like. Right, so the vertex, again, is -4, -12. Axis of symmetry, I actually did draw it here. The graph does keep on going. So again, if you leave the arrows off, I'm not going to take points off, but I just feel better putting them in. We have the y-intercept, as you can see. We have the x-intercepts as well. So that's good. All right. Do you have any questions about this one? I mean, I really hope everyone understands this. I mean, even though we couldn't factor it, the quadratic formula basically helped us. So. Okay. Well, let's go back to the other form, the standard form, right? Remember, this is the standard form. It's another way to write the quadratic function. It's just that here, the hk is the vertex. The a is actually the same. And notice we have x minus h here. It has to be minus, and here it has to be plus. Well, another advantage of this form is if you know the vertex and you know another point on the graph, you can easily obtain a formula for that quadratic function. So if you know if you want a quadratic function such that this point is the vertex and we know the graph passes through a different point, you can actually find a formula easily using this. You can do that. Namely, since the vertex is 2, 0 in this case, and let's say the point that it passes through is 1, 3. Okay, well, if the vertex is 2, 0, that means the point 2, 0 has to equal to the point hk. So 2, 0 has to equal to hk. And remember, if 2 points are equal, their coordinates have to be the same. So the x coordinates are the same. So in other words, 2 equals h, which means h equals 2, and 0 equals k, so k is 0. So this quadratic function is going to look like this, as you can see. But wait a minute, what about this a? Well, we know it also passes through the point 1, 3, right? Well, if the graph of this if the graph contains the point 1, 3, this means f of 1 has to be 3. So when x is 1, f of x must be 3. So in other words, we have to have this. Okay, we can use that to figure out a. Namely, if we replace x by 1, right, we have to get 3. So we have this equation. So this stuff I just summarized from before up here. So this has to hold. When x is 1, we have to get 3. So we have this equality. And now we can figure out a is, right? I mean, over here you have a times 1 minus 2 squared, a times minus 1 squared, which of course is just a. So we have 3 equal to a, and so our function is this, 3 times x minus 2 squared. Okay, so that's what our function is. This is the quadratic function in standard form with vertex 2, 0, and it passes through the point 1, 3. And we can also graph it just to be sure. I graphed it in Desmos, right? As you can see, the vertex here is 2, 0. It should be pointing upward because a in this case is 3, which is positive. And just by coincidence, when x is 1, 3, right? When x is 1, f of x, as you can see, is 3, the y coordinate. So that's what we get. Do you have any questions about that? Yeah.
So do you mind going back a slide and explaining how you got the f of 1 equals 3?
Oh, because it was given that the graph, the quadratic function, passes through the point 1, 3. So what that means is 1, 3 is on the graph of the quadratic function. And another way of saying that is when x is 1, f of x must be 3. So f of 1 has to be 3.
Oh, so you didn't plug it into the equation?
I plugged in x equals 1, and I set the equation equal to 3, because we know that has to be true because of this. Right, so far from knowing what the vertex is, we got f of x equal to this, a times x minus 2 squared, right? But we don't know what a is. But when x is 1, the whole thing has to equal to 3. That's what this is saying. So we have 3 is f of 1, but f of 1 is also equal to this. Because for any x, f of x is equal to this. So we have this equation, which really means 3 is equal to a times 1 minus 2 squared. And here I'm just doing the calculation to figure out what a is. Does that help, or?
Yeah, I think so. Thank you.
Okay, you're welcome. I know it's not easy, I understand. Good question though. And are there any other questions? And again, as a check, I just sketched the graph of what we got. And yeah, the vertex is 2, 0, and it passes through the point 1, 3. So we do get that. I mean, you could also use the other form if you wanted to. I just think it's going to be a lot more complicated. So that's just me, though. All right, so let me see. How much time do we have left? We've got like less than 10 seconds. We've got about 10 seconds left, so I'm going to stop here. And we'll finish this section next time. And then what we're going to do, we will begin 3.3, which is division of polynomials. Okay, so let's stop here.